Well, now that we've come to the end of this unit, you're probably preparing yourself for a test. So let's have a quick look at what we have covered throughout this unit. Well, we started off with looking at the Cartesian plane that was given to us by René Descartes, and we have the x-axis going across the page, and vertically we have the y-axis. We also had 4 quadrants starting at the top right hand corner, quadrant number 1, and then heading anti-clockwise. We also learnt that the origin is the coordinate 0, 0 in the middle of the Cartesian plane. We learned how to plot points. We learned that if we had a series of points, in this case 4, 2, that the x coordinate always comes first. So 4, 2 would mean 4 across in the x direction and 2 up in the y direction. One of the key things that we needed to learn was where is the y-intercept and what does that tell us. So in the table, on the top there, we found that the y-intercept is where the x value equals 0. So you look across to 0, go down, and you find the y-intercept. We also looked at the graph, and on the graph we found the y-intercept is where the line crosses the y-axis. And once again it has a coordinate of 0, 1, and it's the 1 part that we use. And then we place that in the rule. And so it ends up being the last little part of the rule, the constant term, the one without a variable. Another key thing that we needed to find was the gradient, how steep the line was. Once again, if we looked at the table, what we could do is we could work out how the numbers are moving. So in this case, from -1 to 2, it meant that the x value moved 3 places across the page, and that was called our run. And our y value in this case went 6 places up the page. So from -1 all the way up to 5 has a rise of 6. So 6 over 3, which would be the same as 4 over 2, comes out to be the number 2. So if I was looking at a graph, I do the same thing. I just identify 2 points on the graph. I do my rise, in this case 4, my run 2, and it ends up being the same gradient. That value goes in front of the coefficient. So the rule therefore would be y equals 2x, the gradient 2, and the y-intercept 1, 2x plus 1. So we just did a few exercises where we needed to do this without the table. So in this case, looking at the graph, found 2 spots on the graph that I can identify, counted across the page and up the page. So my rise was 6 and my run was 2. We also realised that it didn't matter whether you had the triangle under the line or above the line, as long as you get the order correct. We also had to recognise that this graph is going up towards the right hand side, so therefore it's going to be a positive gradient, positive 6 over 2. If it was travelling up towards the left, then it would be a negative gradient. So we take the key values, the gradient 3, the y-intercept 1, place it in the right place of our rule, and we end up with a rule y equals 3x plus 1. We also had some more trickier examples of where we only had a couple of points. We didn't have a table set up, we didn't have a rule set up. So I'll just go through this example. There is a rule that we can use to find this, but I often find it easier just to place the values in a table. So if I had -3, -5 as one of my points, place it in the table, place the second point in the table, and now I want to look at how things are changing. So from going from -3 to 2, those points have a difference of 5. They are 5 spaces across the page. The y value has a difference of 10. That's a height difference of 10. So my rise is 10 and my run is 5. So therefore my gradient was 2. So I already have part of the rule. I know that y equals 2x, so that's the gradient 2, plus c. Now in order to find the c, I use the gradient part. So if I went back and had a look at the 2, 5, what should be happening is when I multiply the 2 by 2, I should get an answer of 5, and I'm not. I'm getting an answer of 2 times 2 is 4. So what must be happening is I need to add an extra 1. So what you can do is just put the numbers in. The y value was 5, the x value was 2, find out what is missing, you'll find out that the C is worth 1. If I was going to do it by the rule, you may remember the rule was take the second value and take away the first y value, take the second x value, take away the first. So that rule there is just doing exactly what we did with the table. It's just working out the difference between the 2 points. Alright, we also looked at some patterns and how we can transfer the information from a pattern into a table. So in this case I have a series of triangles being added, and I want to count how many triangles I get with the number of matchsticks being used. So I'll start off filling in my table. I'm going to start off with 0, even though there's no 0 triangle apparent. If I had 1 triangle, it takes 3 matchsticks. And then for 2 triangles I need to add an extra couple, so it was 5 and then 7 and then 9. Now if I work my way backwards, what that's saying is I need 1 matchstick to begin the pattern. So if I have 1 matchstick and then I just keep adding 2 more, then I'm going to keep my pattern going. So how is this changing? These are going up by 2, these are going across by 1, so my gradient is rise of 2, a run of 1. My C value, that is my y-intercept, is a 1. So we worked out that the rule is y equals the gradient times x plus the y-intercept of 1. We also looked at how we can find the x-intercept. In this case, to find the x-intercept, we have to use y equals 0. So on the left hand side here we're looking for the x-intercept. I start off with a rule, it could be written in any format, and I replace the y value with a 0, work my way down until I get a solution for x. On the right hand side here I'm finding the y-intercept, so I'm using x equals 0, I replace the x with a 0, work my way down, and I end up with an answer. We also looked at some non-linear graphs, and we worked out that the easiest way to do these was to set up a table of values. To complete the table of values, now you may recall that there was some technique that we had to use when using our calculator. So if I wanted to square the number -3, I just need to be very careful that I put the -3 in brackets before I square it. And then we plotted the points. Had a nice smooth curve. So what more can you do to revise? Well, firstly, there are plenty of exercises on Mathletics that you need to complete. Alright, they'll give you instant feedback about how you're going and whether you're getting any of them wrong. Hot Maths, you have registration for Hot Maths. There are a lot of widgets that allow you to play around with the graph. You can move the graph to a different position and then calculate the gradient and calculate the y-intercept. I suggest you go over the videos again. You don't need to write anything down necessarily, but if you look over them you will find some extra bits and pieces that you may have missed. If you go onto Ivanhoe Connect, there is a folder set up called Student Resources, and in there are some work documents on how to do most of the things, how to find the gradient, how to find the y-intercept. At the end of most of those how-to documents there is also a couple of practice sheets, and some of them do have answers with them. At the end of every chapter there is a chapter review, there is a summary page, and there is then some revision questions. Now you should be completing a summary of your own, regardless of whether you're allowed to bring it into the class or not. That summary page is very useful for you to constantly go back and review and look at. All the best. Hopefully you do very well in your test, and make sure that you do your revision well and truly beforehand so that you can go to your teacher if you're unsure and ask before the day of the test. All the best.